Hello everyone, welcome back to our math class. In this video, we are going to look at the graph of exponential function, and we are going to analyze some key features of exponential function. Let's have a quick review to start our lesson. First of all, let's look at the function of 3 to the x power plus 1 and the graph of this function also given. We are going to answer several questions here to give a quick review regarding some key features of this graph. First of all, let's find the 2 points. Let's see, we want to find the points with, let's see, these 2 points because this is a clear location we can find. So this one is 0, 2, the other one is 0, 1, 4. And also for y-intercept, as we mentioned, this is just a graph where a intercept y-axis. So this is 0, 2, or we can just write down y equal 2 for this. For the graph, as we mentioned, this graph, if you pay attention to how the graph goes 2 directions, they both have no interaction for, no matter 2 sides, no interaction for the x-intercept. So that's why there's no x-intercept in this situation. And the domain from the left to right, the graph, the curve is going continuously. So it's going to consider no all real numbers, or we can just write down by using interval notation, which is negative infinity to infinity. Last part is going to be range. This time I want to spend a little bit longer on this one because if you check the graph carefully for this part, and you would notice on this part of the curve, let's use a different color. This part of the curve as you go is actually approaching to this line here. The horizontal line, as you can see there. So that means we do not see any graph under this line. So that means there's no graph presenting, no graph is presenting under this line, which means y is only goes beyond 1 and above. So that's why we can just present it as greater than 1, or you can write down 1 as positive infinity. Also, some students might notice that even we say approaching, but look like it's actually touching the line, just because this is how much window we can see the graph. But if we actually zoom in, you will notice no matter how far we go, the curve is only getting closer and closer to this line. Since this line has such a special feature, because the curve is actually getting closer and closer to that, so this line we actually have a special name. In this lesson, that will be the major focus for this topic. So this line, we actually have the name for that, which is called asymptote. So let's quickly check what is the definition for asymptote. Asymptote is a line that the graph of function approaches. Keyword is approaching, is not touching, meets, that never touches or never meets as it goes towards infinity. So different situations, different type of function might have horizontal asymptote. Sometimes we even have vertical asymptote. It's for different type of function do have different situation, or even have combined type of asymptotes. So let's quickly check the example we are going to work on and has a better understanding for this idea asymptote. So we're going to do a quick practice. In this practice, we're going to draw a line of asymptote, and also we are going to determine what is the equation for this line. And as you can see, when we observe this graph here, the curve as we go is actually approaching to this horizontal line here because it's getting closer and closer, right? So we are going to draw this line. I'm going to use a tool here so it's easier to see. So this line is actually getting closer and closer. So that's why this is our asymptote in this case. And we also notice it happened to be the x-axis in this case. But since we're talking about, in this one, we're talking about horizontal asymptote. So let's quickly write down the equation. Since it's a horizontal line, which means the line always have equation y equals something, because all the points on this line have a same y coordinate. But what is the y coordinate here? As you can see, the graph actually touching the y-axis at 0, so that's why this equation is y equals 0. Okay, let's quickly check another example here. Again, let's quickly draw this line and then we can have better understanding. This time, let's draw the different color. So as you can see, even the graph is a flip over according to the y-axis, but you can see when we observe this part of the curve, it's also approaching this line here. So let's quickly draw the line here. And also, you probably noticed that this time the line is not x-axis anymore, but it's still a horizontal line. So in this situation, in exponential function, we're majorly talking about the horizontal asymptote. So question is, since we know this horizontal line, so it's always y equals, then what's the value? Here, they intersect at y-axis at -1, so this line is y equal -1. So this is how we identify the asymptote based on the graph, and how do we use the line here to write down the equation. So this is just basically introduction for the asymptote. And the reason we do mention this feature because exponential function is a special function which does have this feature. The functions we had before, like linear function, quadratic function, or polynomial function, they do not have such features. So that's a new type of feature we have here. In the future, we're gonna have more functions have the similar situation. They do have different type of asymptote. Sometimes they have vertical, sometimes they have horizontal and vertical asymptote. Okay, so I hope this video is helpful, and thank you so much for studying this topic with me. See you soon, everyone.